Hi, I am Ms. Sushma, working as Assistant Professor in the Department of EC in Institute of Aeronautical Engineering College, Hyderabad. In this session, we are going to discuss about the time domain analysis of discrete time systems. Here, there are two methods for analyzing the response of a linear system to a given input signal. So, the first method is the input signal is resolved into sum of elementary signals. Then, using the linearity property of the system, the response of the system to the elementary signals is added to obtain the total response. So we discussed about the convolution sum in the previous classes. So in this session we are going to discuss about the second method, that is based on the direct solution of the difference equation representing the system. So here we are going to analyze the response of the system in the time domain analysis of discrete time system. So here the second method is based on the direct solution of the difference equation representing the system. So the general form of difference equation. So here the output depends on the by seeing this difference equation we can analyze that when the output depends on the previous outputs, that is past outputs, as well as present and past inputs. So if we substitute k is equal 1, we will get here a1 y of n minus 1. If we substitute y of n minus 1. If we substitute k is equal to a2 y of n minus 2. Like that, we will get an y of n minus n. Okay. So the first term indicates the output depends on the past outputs, as well as in the second term, if we substitute k is equal 0 in this, k is equal 0, you will get b0 x of n plus, if you substitute k is equal 1, b1 x of n minus 1 plus b2 x of n minus 2. Like that, we will get bm x of n minus n. Okay. So here x of n is the present input. These are the past inputs. So this is a general difference equation. We are representing y of n in terms of past outputs, present input, as well as past inputs. So here ak and bk are these two are the arbitrary constants. So we have to analyze the time domain analysis by using the difference equation. So here the response of any discrete time system can be decomposed into zero state response as well as zero input response. It is the sum of zero state response plus zero input response is the total response of any discrete time system. So here what is zero state response? Here the zero state indicates the zero state response of the system is the response of the system due to input alone. So the initial state of the system is 0. We have to consider the initial condition, whatever the initial conditions of the system, we have to assume the initial conditions as 0, and the system will depend on only input in the zero state response. So here the initial conditions are in zero state response, initial conditions are 0 and it depends on only input alone. Okay, it depends on input only. Okay, so the system is initially relaxed at time n is equal 0. So what is a zero input response? The zero input response depends only on the initial state of the system. So here we have to assume input to the system, whatever the system LTI system is there. We are going to find out the response of the LTI system either by using convolution sum, otherwise we can by solving the difference equation of the time domain analysis of the discrete time system. Okay, so here we are giving x of n, we have to find out the response y of n. Okay, so here this system has two responses, zero state response and zero input response. In zero state response, the initial conditions are 0. For this, we have to assume initial conditions of the system are 0 and it depends on the only input only. When we are giving the input, now what is the response? We have to find out. That response is zero state response. What is zero input response? Zero input response depends only on the initial state of the system. So here we are not giving any input. We have to take the input is 0. So here input is 0 and it depends on initial conditions. It depends on initial state of the system. Initial state of the system. So the combination of 0 state response as well as 0 input response is known as the total response of the discrete time system. So for example, we are taking a first order difference equation here. Y of n is equal a into y of n minus 1 plus x of n. So where x of n is the input, y of n is the output. So here let the input sequence x of n is equal 0 for n less than 0 and the initial condition of the of y of n for n is equal minus 1 exists. So here we are taking the conditions x of n is equal 0, x of n is equal 0 for n less than 0 and we will get the input n greater than or equal 0 only. And the condition for the initial condition is y of n exists for only n is equal minus 1, that is y of minus 1 exists. Y of minus 1 is not equal to 0. So we have to take these conditions, two conditions. We are taking first order difference equation. In that substitute n is equal 0. Here what is the equation? Y of n is equal a into y of n minus 1 plus x of n. Substitute n is equal 0 here. We will get y of 0 is equal a into y of minus 1 plus x of 0. So this equation we are going to get y of 0 is equal a into y of minus 1 plus x of 0. For n is equal, substitute in equation 1, substitute n is equal 1. Here y of 1 is equal a into y of 0 plus x of 1. So already we know the value of y of 0 here by substituting n is equal 0. Substitute that value here. We will get the y of 1 is equal a into y of minus 1 plus x of 0 plus this term x of 1. Finally, we are going to get y of 1 is equal a square y of minus 1 plus a into x of 0 plus x of 1. So like that we have, if we substitute n is equal 2, then what is the equation here? Y of n is equal a into y of n minus 1 plus x of n. So substitute n is equal 2 here. Y of 2 is equal a into 2 minus 1 is y of 1 and x of 2. We are going to get y of 2 is a into x of n plus y of 1 plus x of 2. So we have to substitute y of 1 value in the y of 2. We are going to get the y of 2 value is a cube y of minus 1 plus a square x of 0 plus a into x of 1 plus x of 2. So if we consider this equation, if we write the general difference equation for that one, so for any n, substitute any n, y of n is equal, we can write here, if we have it here 2, a power 2 plus 1. So if we write y of n, we can write as a power n plus 1 y of minus 1 plus here a power 2. So here whatever value we have here, we are getting here. So a power n into x of 0 plus a power n minus 1 into x of n plus x of n. So here we are writing that the general difference equation is y of n is equal here a power n plus 1 y of minus 1 plus sigma k is equal 0 to n a power k x of n minus k. Here we discussed that one, we are taking it is for n greater than or equal to 0. So here the total difference equation for first order system is suppose if we substitute n is equal to here, n is y of 2 is equal a power 2 plus 1 a power 3 a cube into y of minus 1. So first term we are getting plus if we substitute k is equal 0 a power 0 into x of n minus 0, that is a power 0 is here a power, this is n a power n into x of n minus 2. So here we will get a power 2 into x of 0 a into x of minus 1 x of 1 plus x of 2. So we are getting the first order difference equation is y of n is equal a power n plus 1 y of minus 1 plus sigma k is equal to 0 to n a power n x of n minus k n greater than or equal 0. So here by observing this difference equation, so output depends on the y of minus 1, that initial conditions as well as present and past inputs. Okay. So here the response y of n includes two parts. The first part depends on the initial condition of the system and the second term depends on the input. So here when y of minus 1 is equal 0, here we have total response is equal 0 state response plus 0 input response. In 0 state response, in first if we go for 0 state response, here we have to take the whatever the initial conditions are there, we have to assume that are 0, and that the system, we have to find out the response when the system depends on only input. So here in the here we got the difference equation y of n is equal to a power n plus 1 y of minus 1 first term, and second term is sigma k is equal to 0 to a power n x of n minus k. So the first term depends on the initial condition. So if in the 0 state response, the initial conditions must be 0. Okay, so here the initial condition y of minus 1 will be 0. So we are taking y of minus 1 is equal to 0, and the output depends only on the input in the 0 state response. We can call this 0 state response as forced response also. We can call 0 state response as forced response. So here the forced response will depends on only the second term input. The first term we are making y of minus 1 is equal to 0 because in 0 state response the initial conditions are 0. So here by forced response will depends on only input. The initial conditions are 0. If the system is initially non-relaxed, that is y of minus 1 not equal to 0, and the input x of n is equal to 0, then the system response is the 0 input response. We have to find out the 0 input response when the input is equal to 0 and initial conditions not equal to 0. So here in the equation, first term is a power n plus 1 y of minus 1. So it depends on the initial condition. The second term depends on the input. So the second term we have to make equal to 0 because in 0 input response, input equal 0. So here the 0 input response equal to a power n plus 1 y of minus 1. So here 0 input response is also called as the natural response. Here 0 input response is called as natural response of the system, whereas 0 state response is called as the forced response. Okay, so here the total response will be equal to the natural response plus forced response, that is nothing but 0 input response plus 0 state response. Here in brief, if we discuss, 0 input response is obtained by letting the input signal to 0. It depends on the nature of the system and initial conditions. On the other hand, the 0 state response depends on the nature of the input signal. So here it 0 state response, we have to make the initial condition 0. So it depends on the nature of the input signal, whether input signal is impulse signal, unit step signal, whatever the signal, it depends on the nature of this signal. So the difference equation of the nth order discrete time system can also be written as here sigma k is equal 0 to n a k y of n minus k is equal sigma k is equal 0 to m b k x of n minus k. We can write this as also. So a naught, if we substitute k is equal 0, we can write a naught y of n plus sigma k is equal 1 to n a k y of n minus k is equal sigma k is equal 0 to n b k x of n minus k. So we are taking a naught is equal here 1. So y of n we can write as, if we take this term to the right side, minus sigma k is equal 1 to n a k y of n minus k plus sigma k is equal 0 to n b k x of n minus k. So general nth order difference equation, the output depends on the past outputs as well as present input and past inputs. So here where n is the order of the system, capital N is the order of the system. If the coefficient A0 is equal to not equal to 0, that is A0 we are taking 1, then we can divide the above equation through the by A0 equal to normalize the equation. So here the total response of the system for the nth order system is equal to the homogeneous solution plus particular solution. Homogeneous solution plus particular solution. Here where YH of n is the homogeneous solution, whereas YP of n is the particular solution. We will discuss what is a homogeneous solution and what is particular solution also. Here the total response is equal to the homogeneous solution plus particular solution. So first of all we will discuss how to find out the natural response and the forced response of the system. Here natural response is also called as the zero input response. Okay, in zero input response it depends on the input is 0, we should make the input is equal to 0. It depends on the initial conditions of the system. So the natural response YH of n is the solution of the below equation with input x of n is equal to 0. So here we have to find out the solution for the difference equation. The solution is called homogeneous solution. How to find out the homogeneous solution? Here we are taking the nth order difference equation, general nth order difference equation. So here zero input response, the name indicates the input to the system is 0. We have to find out the response for the system when input is equal to 0. So we have to make the whatever the input terms in the difference equation, we have to make them equal to 0. So therefore this term will be is equal to 0. So therefore the discrete system, the natural response is the solution of the homogeneous equation. So here we have only sigma k is equal 0 to n a k y of n minus k is equal 0. Because we are taking it is a zero input response, we are making the input terms are equal to 0. So that's why this term k sigma k is equal 0 to m b k x of n minus k is equal to 0. And substitute here in difference equation YH of n is equal lambda power n. We have to substitute YH of n is equal lambda power n, and we have here sigma k is equal 0 to n. Difference equation is y of n minus k is equal 0. So when input is equal 0, we have to find out the solution. That solution is called homogeneous solution. So here substitute YH of n is equal lambda power n, that is y of n wherever there lambda power n you have to substitute. If it is y of n minus 1, we have to substitute there lambda power n minus 1. Y of n minus k, we have to substitute lambda power n minus k. So here sigma k is equal 0 to n a k. This 1 of n minus k we can write as lambda power n minus k, that will be equal to 0, and where a naught is equal to 1. We have to take a naught first arbitrary constant where n is equal to 0, k is equal to 0, we have to assume that is equal to 1. And if we expand that one, we will get lambda power n, a1 lambda power n minus 1 plus a power n minus 1 lambda power n minus n plus 1 plus a n lambda power n minus 1 is equal to 0. And we have to write the characteristic equation from that equation. Okay. And we have to find out the roots for that characteristic equation. So here the polynomial of the above equation is called the characteristic equation of the system. Now the nth order characteristic equation can be expressed in the factorized form as. So we have to find out the factors of this. We have to find out the factors for this characteristic equation. Characteristic equation. If it is nth order system, we will get the roots are, factors are up to lambda 1, lambda 2, lambda n. So we can write this equation in terms of lambda minus lambda 1 into lambda minus lambda 2, lambda minus lambda 3, up to it is nth order system, you will get the lambda minus lambda n is equal to 0. If we have the third order system, we will get the lambda minus lambda 1 into lambda minus lambda 2 into lambda minus lambda 3 is equal to 0. We will get the 3 roots for that. If it is a fourth order system, we will get the 4 roots for the characteristic equation. So here we have nth order system, we have lambda n roots and we have to find out the nature of the roots. Here, the nature of the roots will decide the homogeneous solution response here. Okay, if the roots are real or if they are imaginary and complex or they are repeated roots, we have to first identify that one, and according to that one we have to write the homogeneous solution. If the roots are distinct roots, so here whatever the roots for the characteristic equation we are going to get, if the roots are lambda 1, lambda 2, lambda 3, lambda n are distinct roots, okay, then it has n solutions. So in this case, the general solution is yh of n is equal c1 lambda 1 power n plus c2 lambda 2 power n plus cn lambda n power n. So c1, c2, cn are the constants here, arbitrary constants. Lambda 1, lambda 2, lambda n are the roots of the characteristic equations. For example, for second order difference equation, if we got the two roots, lambda 1, lambda 2 is equal 2, 3, that is lambda 1 is equal 2 and lambda 2 is equal 3. Then directly we can write the homogeneous solution. yh of n is equal c1 2 power n plus c2 3 power n. We can write like that. Suppose if we have lambda 3 is equal 4, we can have another constant. If we have third order system, we will get the 3 arbitrary constants, c1, c2, c3. If we have the fourth order system, we will get the c1, c2, c3, c4. Here, if we have the another root is 4, then we can write c3 4 power n. So, if we know the roots, whether they are distinct roots or repeated roots, from that we can directly write the homogeneous solution. After that, we have to solve the c1, c2, c3 values and we have to substitute here. Okay, so here example 2, 3, we can directly write c1 2 power n plus c2 3 power n. If the roots are repeated roots, the suppose if first case we will take the repeated roots. Suppose if I have lambda 1, lambda 2, lambda 3, 3 roots, I will got the 2, 2, 2, then we can directly write the solution as c1 plus c2 n plus c3 n square into 2 power n. Okay, first this one c1 plus c2 n plus c3 n square plus cm n power n minus 1 into lambda 1 power m. And if we have the first roots have the repeated roots and up to m, and n minus roots are distinct roots. That is nothing but I have 2, 2, 2, 3, 4. My roots for the characteristics equations are 2, 2, 2, 3, 4. If I have the repeated roots as well as distinct roots, how to write the homogeneous solution is c1 plus c2 n plus c3 n square plus cm n minus 1 lambda 1 power m. For this is for the repeated roots. This is for the repeated roots. If we have the 4 repeated roots, we will get here 4 constants c1, c2, c3, c4. If we have 5 roots, we will get c1, c2, c3, c4, c5. Okay, and next root will be, suppose I have 4 roots here up to c4n cube I will get here, and here this root is c5 into lambda 5 whole power n and c6 into lambda 6 whole power n. Like that we have to write. So here directly the homogeneous solution I can write is yh of n is equal, I have here 2, 2, 2 and 3, 4. So 2, 2, 2, I have 3 repeated roots. So I will get 3 constants here, c1 plus c2 n plus c3 n square into, what is that root? Repeated root 2. So 2 power n plus, and I have 3 and 4 are the distinct roots. So that constant I will get is c4 into 3 power n plus c5 into 4 power n. Like that we can write the roots. If they are repeated roots, we can write the c1 plus c2 n plus c3 n square 2 power n. And as well as if we have repeated plus distinct roots, we can write the constant like that. Okay. Suppose I have, for example, if the roots are characteristic equation are lambda 1 is equal to, lambda 2 is equal to, lambda 3 is equal to 3. then the solution will be, here we have 2, 2, 3. So 2 repeated roots. So here constants C1, C2, C3, 3 constants we will get here. So first roots are repeated roots. So I can write that as C1 plus C2n into 2 power n repeated root power n plus C3 into the third root is 3. So 3 power n. So this is directly we can write the homogeneous solution like this. If the roots are complex roots, that is, if we have roots 1 minus jb, 1 minus 2, 1 minus 1 plus 2j. If the roots are complex roots, like 1 minus 2j, 1 plus 2j, 1 minus j, 1 plus j like that, then we can write the solution. Suppose first root lambda 1 is equal to a plus jb, lambda 2 is equal to a minus jb. Then the homogeneous solution is of the form yh of n is equal r power n a1 cos n theta plus a2 sin n theta. Thus directly we can write the solution. Here yh of n is equal r power n a1 cos n theta plus a2 sin n theta. So here our r is square root of a square plus b square, theta is equal tan inverse b by a. So here in the natural response, that is 0 input response, we have to find out homogeneous solution. Homogeneous solution. Here we have to take input is equal 0. Whatever the terms in the difference equation, input terms, we should make them equal to 0 and substitute y of n is equal lambda power n. And write the characteristic equation. Write the characteristic equation. Lambda minus lambda 1, lambda minus lambda 2. We have to find out the roots. And according to nature of the roots, we have to write the direct homogeneous solution and find out the constant C1, C2, C3. Okay, this is the natural response or zero input response. So for forced response, what is forced response is also called as a zero state response. Here the name indicates zero state. Here the initial conditions, whatever the initial conditions for the system, we have to assume them equal to 0 and it depends only on the input. Okay, whenever we are giving the only on the input, what is the response of the system, we have to find out the here. So the forced response is the solution of the difference equation for the given input when the initial conditions are 0. Initial conditions are 0. That is, forced response is the response of a relaxed system for any input x of n. So it consists two parts, homogeneous solution plus particular solution. So homogeneous solution already we discussed in the natural response, same procedure. We have to make the input term equal 0 and we have to find out the characteristic equation and roots of the characteristic equation. From that we have to write the yh of n. But in the particular solution, particular solution is it depends on only input signal. So n greater than or equal to 0. Okay. For impulse signal, the particular solution is 0. We have to write the particular solution is equal to 0. So here for particular solution, to write the particular solution of the system, we have to remember this table. Okay. If the input signal is constant or unit step signal, okay, then the particular solution is k. For example, I have y of n is equal 2 into u of n. Okay, then we can write particular solution is 2. Okay, only we have the constant k. So 2 into k. Particular solution is only k here. Particular solution is only k. Okay, and if we have the input signal in the form of a into m power n, the particular solution is k into m power n. So here, suppose I have 2 power n into u of n. My input x of n is equal 2 power n into u of n. See here, we can write this as 1 into 2 power n. So that is 1 is m power n. Both are constant here. So a into m power n. Then the solution, particular solution we can write as yp of n is equal k into 2 power n. K into m power n. Okay, so k is constant, m power n we have here in the input, that we have to write here k into 2 power n. Okay, like that if we have the input a into n power m, a into n power m, that is n cube, n square. If we have like that input, we have like that, then we can write the different particular solution is k naught n power m plus k1 n power m minus 1 plus k into up to k m. If we have the input a power n into n power m, then a power n k naught n power m plus k1 n power m minus 1 plus k. If we have the input like a into cos omega naught n, a into sin omega naught n, then directly we can write the particular solution is k1 cos omega naught n plus k2 sin omega naught n. So here, if we remember this table only, we can write the particular solution of the system. So we should first analyze the what type of the input signal, what is the nature of the input signal, and according to that we have to write the particular solutions. So directly we have to particular solutions for that, and we have to find out these constants k naught, k1, km, k. Okay, these constants we have to solve in the particular solution. So we will see one problem on this one. How to find out homogeneous and particular solution. Here the difference equation here is y of n is equal y of n plus y of n minus 1 minus 6 y of n minus 2 is equal to x of n, where x of n is equal 8 into u of n, y of minus 1 is equal 3, here y of minus 3 is equal minus 1. So here to find out the homogeneous solution, what we have to make? We have to take the input term equal to 0. So in the difference equation, so here this is the difference equation y of n minus 2. So this is the second order difference equation. So here in this is equal to x of n. Input terms are only we have x of n. We should make them equal to 0. So we are going to get y of n plus y of n minus 1 minus 6y of n minus 2 is equal to 0. Okay, in homogeneous solution we have to make the input terms 0 because it is a 0 input response. Here, and substitute yh of n is equal lambda power n. Wherever the y of n is there, substitute here there lambda power n. You will get lambda power n plus lambda power n minus 1 minus 6 into lambda power n minus 2 is equal 0. If we solve this characteristic equation, here we will get the roots are lambda 1 is equal minus 3 comma lambda 2 is equal 2. Okay, we have to write the characteristic equation and find out the roots for that one. It is a second order system, so we will get the 2 roots for this one characteristic equation minus 3 comma 2. So here directly these 2 are the distinct roots. Directly we can write the homogeneous solution as C1 lambda 1 power n plus C2 lambda 2 power n, that is C1 minus 3 whole power n plus C2 2 power n. This is homogeneous solution, right? This as equation 1. In particular solution, if we go for particular solution of the system, if we depends on particular solution depends on the nature of the input. X of n is equal to 8 into u of n. X of n is equal 8 into u of n, and y of n plus y of n minus 1 minus 6y of n minus 2 is equal to 0. Is equal to x of n. Okay, so is equal to x of n. So here in the table, from the table we discuss about the particular solution. If input in terms of x of n, input in terms of constant or unit step, then the solution is k. Yp of n is equal, solution is equal k. So here the particular solution we can write as K. Okay, substitute this K in the this difference equation. So y of n is also K. This is also K. 6 minus K is equal. X of n is 8 here. Okay, 8. Okay, so here we will get the K value is minus 4K is equal 8. K is equal minus 2. So the particular solution we are going to get is here minus 2. Okay, so here we have if we want to find out the total response of the system, it will be equal to the y of n is equal to the homogeneous solution plus particular solution. Or we can write the y of n is equal natural response or forced response. Either anything we can find out. Here we are going to find out the homogeneous solution plus particular solution. So here the equation for what is homogeneous solution here? C1 minus 3 whole power n plus C2 2 power n, whereas yp of n is equal minus 2. So write this here C1 minus 3 whole power n plus C2 2 power n by a particular solution is here minus 2. So, but we have to find out the values of C1 and C2 by using the initial condition from the system. So, initial conditions they given is y of minus 1 is equal to 1, y of minus 3 is equal minus 1. So, here y of n, what we got here, y of n is equal C1 minus 3 whole power n plus C2 2 power n minus 2. Okay. So, substitute n is equal minus 1 here. Minus 1, we will get y of minus 1. C1 minus 2 whole power minus 1, we can write that as minus 1 by 3 plus this we can write as C2 by 2 minus 2. Okay, what is y of minus 1 in the problem? In the problem they gave that as 1. So, this will be equal to 1. So, this is equation 1. So, substitute n is equal minus 3. So, y of minus 3 is equal C1 minus 3 whole power minus 2, that we can write as minus 1 by 9 C1 plus 1 by 6 C2 minus 2 is equal. What is n is equal minus 3 value here? Minus 1. So, substitute this value here minus 1 equation 2. Sorry, it is n is equal minus 2 only. N is equal minus 2. So, n is equal minus 2. So, substitute from the initial condition they gave minus 1 y of minus 2 value. So, substitute those values n is equal minus 1 minus 2 in the this equation, and you will get these two equations and solve these two equations 1 and 2. Solve 1 and 2 equations, we will get C1 is equal minus 1.8 and C2 is equal 4.8. Directly we can write the final response is C1 is equal, here substitute in this equation minus 1.8 into minus 3 whole power n plus C2 is 4.8 into 2 power n minus 2. So, this is total response of the system. So, we have to find out the homogeneous solution. Homogeneous solution plus particular solution and solve the constants C1, C2 and K values and find out the total response by using the initial conditions. So, this is the total time domain analysis of the discrete time system. Here, we have to find out the zero input response and zero state response. Also, here the response we can y of n also we can write y of n plus natural response plus forced response. Natural response is the zero input response, whereas forced response is a zero state response. These problems we will discuss in the next session. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.